And this template is what you're gonna use, for all your lab reports. So look at this, what the template have. Starting with physics with calculus 1 lab, physics 2040 AL, lab report. So now lab number, next week will be lab number 1, lab title, right? Next week will be measurements, okay? What is the author? So your name, okay? And then the first you're gonna find here is the abstract. Now remember, I will show you the structure in the order that each section, is there in the lab report. But the abstract is the last part that you're going to write. Why? Because the abstract will be or will contains the conclusions, right? So the abstract contains the conclusions. The abstract contains a description of all you did during your lab, all your results, right? And what you conclude about. And you cannot write the abstract if you don't first do or perform the lab, right? Get the result, analyze the results, etc. Right? So the abstract, regardless, that is the first that we have in first page, and the abstract will be in the first page, right? So first page will contain just only this: the information about the lab title, lab number, the author, and the abstract. But this abstract will be the last part you're going to write. Now, what do we have here? The introduction. Again, the introduction would be a section that you will write just before writing the abstract and after writing all these other sections. Regardless that the abstract and the introduction are just the first two sections, are just the last two sections you're going to write. Okay, you will write about this as at the end. Okay, so what is the introduction going to contain? The introduction is a summary of the general principles, the methods, the results, right? So it's a summary of all the sections you have after the introduction. They say that a good rule of thumb is to include one sentence per paragraph of the already written general principles, methods, and result sections of the lab report. Okay, so here in the introduction, you will summarize everything that you have already written, right? So you have to have this part before writing there the introduction. So what are we gonna do? We're gonna start writing the general principles. What is general principles about? General principles is a section that begins with a discussion of the concepts and the physical principles that we are addressing in the lab activity. The introduction then just move on to a mathematical formulation of these same ideas, right? A derivation of the actual formulas to be used in the activity, etc. That means in your introduction, you're gonna make a description of the main concept, physical principles, and formulas that you are using for your lab. This is what you have in your general principles, right? Now, you have another part here, methods. Method is gonna present, basically a description of the actual experiment in your own words, right? Usually we give you a step-by-step lab procedure. You don't have to write the step-by-step lab procedure. You can just paraphrase this, right? I mean, you can just make your own description of the experiment, okay? You will just mention specific details about the lab equipment, about the if it's a simulation, about the experimental simulation, right? And you will describe the procedure without necessarily, going step by step in this section. So you don't have to go step by step. In the labs, right, that you will find there in the orientation for the labs, you will find step by steps what you have to do. You don't have to put the step by step procedure here in the methods. If you want to include it, that will be fine. If you want to do it step by step. But remember also to include, a description of the simulation you're using, a description of the equipment you are using an equipment, you know. So just not only write that sequence of steps, right? Not only that sequence of steps. Now, after writing the general principles and the methods, you will perform, of course, your experiment, okay? You will perform your experiment. Some experiments are gonna be experiment that you can do at your, home with very, very few resources, right? So we're gonna use maybe a piece of a string. We're gonna use, it could be a rock, or it could be, if we want to make a pendulum, for example, we can just pick a piece of a string and we can use a rock and we get a pendulum with that, right? So very, very simple resources, very resources that are just easy to get, right? So we are not gonna buy any kind of kit, or experimental kit or anything like that, okay? In other labs, we're gonna use computer simulations. Now, after performing the experiment, following the steps that are given, in the orientation of the lab, you will write the results, right? So what do you have here in the results? You give the numerical result of your measurements along with the uncertainty, right? You will provide any supporting analysis with data tables, the calculations graph, etc. You will mention in the results, right, if the experiment you did, confirm or not, your hypothesis. That means what your expectations, right? Okay. If, for example, you are just finding that it's one of the labs, right? For example, the acceleration of gravity, by an experiment on free fall, then you can just, for example, mention if the acceleration of gravity that you have obtained here is in correspondence with the expected acceleration of gravity. You can make an analysis if the numbers are very, very different, of which are the sources of error, that could be affecting your experiment here. So all this is about the results, right? So you will basically present the tables, present graph, explain these tables, explain this graph, So this is a section that, let me say, is probably, together with the conclusions, the most important section, right? Okay, so here is where you present all the data you are collecting. Okay, so they should be there tables with the data. They should be there a graph, maybe in one experiment, you don't have to make a graph, but in some experiment you have to graph. The graph should be there. And your explanation, your interpretation of that results. And then finally, you have the conclusions. So what is the conclusion? The conclusion is also a summary of what your results were, right? So in your conclusions, you will describe your results again, right? So you will mention which are your results. You will explain them. You will explain, if there is correspondence or no between these results and what you were expecting. Okay, so this is what you have to write in the conclusions. Okay, so conclusions together with results are two sections that are very, very connected. Okay, so based on the results, you will conclude about, this or that. Okay, now at the end you have references. You will use reference. Maybe you can reference your book. You can reference any information you get from the internet. You can reference, of course, the website where you have the simulation, if we're using a simulation. So it's always important, to reference, of course, what documents, what resources, right? We use it. When I say resources, I'm talking about videos, documents, books, papers, etc. Simulation, websites, so you can reference this here. Now, you know that there are different citations styles, so we're not gonna be tied to any. You just try to be consistent, okay? So use one style. If it's APA, I'm fine. APA 6, APA 7, or Chicago, or I don't know. I really don't worry about that. Okay, you will use whatever you want, whatever style you want to cite, right? To make your citations, and to write your reference. So this is up to you. So once you have complete all this part, is when you are ready to go to the introduction, and then you will write the introduction. And after writing the introduction, you will go and you will write the abstract. Of course, I include here in this template basically a paragraph that you will delete, right? That you will erase. You will erase all this paragraph, of course, right? But I just include a paragraph with the description, with the description of what the section contains. So my recommendation is use this template. Now, when you are making a table, just make a simple table, a table as simple as possible. One of the things, that I find when I am just grading lab reports, right, in my classes is that some students create like very sophisticated tables, right, but are tables that it's almost impossible to understand, because they complicate the table too much. So you don't have to do that, right? In science, we try to present the results as simple as possible so everybody can understand, right? Every reader, can understand what you wrote over there. This is when you're writing the papers and a story. There are some guidelines you follow, but when you present your results, right, you try to present something that people are going to understand when they read, because you want that your word be applied. You want the people be able to understand your results. So try to simplify your tables as much as possible. Same story with a graph. So don't include information that is not necessary. It don't make sense. That made you understand your work more difficult. And this is not the idea, right? The idea is that everybody that just read the report just understand what the report shows, right? So this is the structure. This template, as I show you, is there in the website. Okay, the rubrics. So how I will evaluate this report. Okay, so these are the criteria. You can just read this carefully later, right? This is what I'm expecting. Okay, so to get the highest score, in this case, they have a report that is have 5 sections. I mean, the rubric that have 5 sections, 1, 2, 3, 4, 5, and they assign 2 points per section. So that is a total of 10 points, right? In my case, I am grading this, over 100. So every section will count 20 points, right? Every section will count for 20 points. Okay, the maximum per section would be 20 points. So to get 20 points, for example, in the general principles, what the general principle must show: a clear discussion of the physical principles to be addressed in the lab. Content and clarity of presentation indicates a high degree of familiarity with the material on the part of the author. So if your general principles meet these requirements, you get your 20 points. Now, progressing, just the half of the points, 10 points. One or more issues that prevents a rating of satisfactory. Non-performance, you get 0 point. So you give me a lab report, you send me a lab report without general principles, you will get 0 for that section, right? So this section is either missing entirely, or the author of the report is repeating issues noted in previous report feedback, or So here is the rubric, okay? This is basically, what are we going to use to uh, grade your lab report. So here you can get an idea what is the expectation. This is the rubric. This rubric is the rubric that we use in Broward College, for the labs. So it's a general rubric for any lab, of any physics lab, right? But at least give you, an idea what is the expectation in a lab report. So super important, this part. So this is Vernier. So it's easy. You can just go and click in the link and you can download this software. It's free, right? So what this software show you, or which are the features that we have in the software, okay? So for example, I can rename the data set if I want. I just call this data set example. I can rename the columns, so I can have column options. For example, I can change the name of the column. I can include units, right? If I want. So I want to say these are meters, and this will be length or width. Oh, come on. Okay, I apply it, and then now this axis is called width in meters, right? I can just rename this again. I will call just like I called this originally, that was just X and no Unix. Click on apply, that's it. Now, what other options I have? I can just make changes here. Again, with the columns, it's basically the same that I had over here in the table. I have these also in my graph. So I can rename, any column, that means any bar, any axis, etc. Now, this option over here, apply curve fit. So this one let you select what kind of function you will use to try, to find the function that describe better the data set you have. So I can pick a linear, for example, and this is just the line. Of course, a linear function here is not going to fit the points, right? I can use, for example, inverse square. I can use a natural exponent. Natural exponent looks like it's the function that better fit the points, right? The data points, the data values we have here. Now, suppose that you say, okay, I will apply this one. Now here you have the equation. Y equals A e to the power of negative cx plus b, where the coefficients are. A 1.924. So y equals 1.924 e to the power of 0.6011x, negative 0.6011x plus is really negative because b is negative, so minus 0.0372. So that would be the equation, right, of the function that better fit, or the equation that better fit, the points, right? So this Vernier is really a very, very simple software. It's very friendly, you can use it as you want. Now, this same example, I did this same example with Excel, using Excel. So in Excel, I hope that you have good skills in Excel. I just type on my data set here. Okay, so we go then to insert. I will insert a graph. I would pick one of these scatter plot graph. Okay, I will make a right click. I will say select data. I will say here add. I will call this example X values. I will just select the X values. Y values. I will select the Y values here. Oh, wait. I will say OK. I will say OK again. And I got my graph. Now, if I want, I can add, axis titles, right? So we call this Y. And I will call this one X. Right? If I want, I can change, I can include data labels if I want. I can add error bars, and I'm going to do that. And I have something that is just the most important feature, that is the trend line with the equation. So we just click on any of the points. I will make a right click, and I will say add trend line. When I say add trend line here, now it shows different trend line options. You can go from the linear. You say display the equation on chart and display the R square value on chart. R square give you an idea, of how good, right? Your equation is describing the data set, right? Of course, this is not really a good option. A linear option here is not really good. So we can just pick another trend line. Okay, so for example, I will say, let me use one exponential. And when I have the exponential, now my R squared is very, very high, and I can just see my equation. The equation, of that describe the data set. So I can present, in my graph, the equation. In some cases, in some experiments, you will have a linear relation, and then they will ask you for the slope. Okay, if they ask you for the slope, you know where the slope is, right? So they ask you to find the slope. Let us say that we have a linear relation here. We say display equation chart, display I square. Then in this equation, the slope is negative 0.1539, right? So that slope in some experiment would be equal to the constant of the spring, or the gravity, or the inverse of the period, or I don't know. So this slope is going to represent something, later in the experiments we're going to be doing. So in a lot of problems, I would ask you for, find the slope, determine the slope of the graph, right? And then base it on that slope. Later, we are going to do all the calculations, right? So I'm pretty